All right, so we'll get right into it. Here's the first example. The easiest and at the core of what an inverse is basically the reverse. Now you should have seen this already as an Algebra 2 topic, so we'll just refresh your memories here. So this is a list of values, and if you write them down as ordered pairs, then you have this setup right here: -30, -22, -10, +14, -5, 23, 0, 32, and 5, 41, and then we have 10, 50. So this is your relation. A relation is a set of ordered pairs. So there's your relation. So when we ask you to find the inverse of that, well, now the inverse relation is simply going to reverse the values so that your domain values will now be your range values, and your range values will now be your domain values. So all it is, here's your inverse relation. You're going to put -22, -30, 14, -10, and 23, -5, 32, 0, 41. That 32 looks pretty weird, right? 41, 5, and 50, 10. Officially, these numbers are actually the Fahrenheit, the Celsius. On the original table, it's the Celsius temperatures converted into Fahrenheit temperatures. But what if we wanted the exact opposite? What if we have the Fahrenheit temperature and I wanted to see how much is that in Celsius? Well, that would be the inverse. So that's when you flip the domain and the range of values. All right, so at the core, that's all it is. That is an inverse relation. Now, as far as what is a function or not, remember that a function, the domain values, the x values, cannot repeat with a different y value. Each domain value can only give you one range value. Since these numbers are actually straight from Fahrenheit to Celsius, and when I reversed them, actually Celsius to Fahrenheit, and when I reversed them, it's Fahrenheit to Celsius, well then this is going to be a function. In other words, if I look at a 32 degrees Fahrenheit temperature, 32 degree Fahrenheit temperature, there's only one temperature that it relates to in Celsius, and that's 0. So you cannot have 32 degrees Fahrenheit and, oh, okay, well, here it's 0 and here it's -5. No, no, no. It's only one answer. 32 is associated with 0. So in fact, this is actually an inverse function. It's not in an equation form, but there is an equation that does transform values from Fahrenheit to Celsius and vice versa, and both of which are functions. All right, let's go ahead and work now on specifics. What if we have a function already given, y equals x squared minus 4. By the way, that is a parabola. So I don't know if you recall, but all you have to do is make your range value, the y, make it into a domain, and make your domain into a range, into a y. And then since all functions have to be written in y equals form, or f of x equals, then you have to leave y by itself. So I'm going to move 4 to the other side, and that's going to be x plus 4, because you're adding plus 4 on one side and plus 4 on the other. So now you have this. Now to get rid of the square, you got to get rid of it with a square root. So you're going to take the square root on both sides. But whenever you take the square root, it's plus and minus square root. It comes from the quadratic formula, that plus and minus. There's a positive and negative possibility. That was from the other unit. All right, so it looks like my inverse would be y equals to positive and negative the square root of x plus 4. That would be the inverse. This is actually a relation. I can tell you it's a relation because in the original picture, in the original diagram right here, this one, that is a parabola that starts 4 units down. So down here at -4, it's a parabola that goes this way and the other way, same, symmetrical, right? Now this other picture, on the other hand, this one is a square root function that starts 4 units to the left. Remember, everything with x is backwards. So if you're seeing that right there, it is actually starting 4 units to the left. And then the positive square root goes above. And then the negative square root is a reflection, which goes to the bottom. And this would not be a function because it violates the vertical line test. So this is not a function. It is actually just a relation. Now, there is something that we're going to study here. So the question for the original statement, find the inverse of that, well, it's the one in blue. But what I was going to talk to you about was this right here. apply the horizontal line test. Remember that on the previous picture right here, this is not a function because it violates the vertical line test. The blue one right here violates the vertical line test. Well, if you know that everything gets flip-flopped when you're trying to find an inverse, like right here, if we look at example A, if I graph example A right here, it's an absolute value function. So it's a V shape that starts 5 units to the right. So we start right here and then it goes one up, one to the right, one up, one to the left. Anyway, that's an absolute value function. If we try to find the inverse of that, you will not have an inverse. So the instructions say apply the horizontal line test to determine whether the inverse function exists. Well, this will not exist because, see, if right now you drew a horizontal line, if you drew a horizontal line and you pass through 2 points of the graph, that is a function right now. But remember, if I try to find the inverse, everything gets reversed. So if you have 2 repeated values horizontally, when you do the inverse, now you're going to have 2 repeated values vertically. So that is going to violate the vertical line test. So what this statement is saying is apply the horizontal line test to determine whether the inverse function exists. In other words, if I do the inverse, will it be a function or not? Well, for the A, it is no, not a function. The inverse, let me write this correctly here. The inverse will not be a function, and that is because if a horizontal line passes through, so right here, I want to put the answer here, the inverse is not a function. All right? The inverse is not a function. That is a complete sentence, so I should do this, right? Okay, the inverse is not a function. And again, the way I knew it is I knew this was a V shape. So if a horizontal line touches more than 1 point, we're not saying that that's not a function. That's a function. But when you do the inverse, you're going to have a picture that looks like this, and the vertical line is going to touch more than 1 point. So that's why if the horizontal line touches more than 1 point on the original graph, then the vertical line is going to touch more than 1 point on the inverse. So the inverse will not be a function. All right, so let's go to the next one. Now you may need to use a graphing calculator for this one. So on this one right here, let's go red on this one here. So on this one right here, if you graph that, that is the function g of x is equal to x cubed minus 6x squared plus 12x minus 8. Well, if you graph that, and you can graph that on your own, I'm going to go ahead and just do a quick sketch of what this one was like. I went ahead and graphed it ahead of time, and I got a picture that looks something like this. And then it kind of goes like that. There you go. So that picture looks like that. If you do a horizontal line, it only touches 1 point, 1 point. It only touches 1 point. No matter where you go, horizontally, it's only touching 1 point. So because it's only touching 1 point, now right here at this, there's a point of inflection. It gets super close. It doesn't flatten out. It kind of just goes a slightly curved, but it doesn't go straight across. It flattens out a little bit. That's your point of inflection. But the horizontal line only touches 1 point at every particular spot. Therefore, for that one, my answer is that it passed the horizontal line test. It passes the horizontal line test. Therefore, the inverse will be a function. So you'll say the inverse is a function. Okay, that's all you're going to have to do here. Apply the horizontal line test to determine if it exists. That's all you have to do. All right, let's go to the next one, and we'll go with a different color here. Let's go green. All right, so this one right here, h of x equals x cubed minus 5x squared plus 2x minus 1. So that one, once again, I went ahead and graphed it. Y'all can graph it, right? Now you can go back and graph it on your graphing calculator. But when I graph this one, it looks something like this. Now I don't have a perfect picture, but it's going to look something like that. So this one will not pass. Look, it's not going to pass the horizontal line test. Because a horizontal line touches more than 1 point, then a vertical line is going to touch more than 1 point on the inverse. Therefore, the inverse is not a function, or the inverse does not exist. The inverse is not a function. Or sometimes you will say the inverse function does not exist. All right, and then I just went ahead and drew another one there at the bottom. Once again, if you have some sort of random picture, if you, like here it only touches ones, here it only touches ones, but at any point in time, if it, so no inverse function. At any point in time, if a horizontal line touches more than one point, then the inverse does not exist, or the inverse function does not exist. So no inverse function for that one either. All right, again, remember you can always pause, rewind, replay the video as needed. Take down some notes as well. All right, let's go to this one. Determine whether the inverse function, if there is an inverse function. If so, go ahead and find it.